my name is Jack Michael. This is Physics 2212, Lab 1, Charge Tape. Brief introduction. The purpose of this lab is to analyze the interactions of two charged objects on one another. We want to be able to compute a specific value of charge and number of excess electrons on the charge tape based on their interactions. And then third and finally, we want to create a computational model of the situation using code in GlowScript. Brief overview of the findings. The findings showed that the U tape, or the charge tape, is positive. The charge is approximately 8.5776 times 10 to the negative ninth coulombs. This means the tape had a efficiency of 5.3543 times 10 to the 10th electrons. So three key concepts or formulas that are going to be integral to the calculations in this lab are Newton's second law, which allows us to show that the net force is zero, which allowed us to set the gravitational force and the electric force, which are these two formulas, equal to each other, and calculate the charge Q, which is provided in Coulomb's law. The procedure is roughly as follows. So for one, you stick a piece of Scotch tape with a handle down to the table. You lay another piece of Scotch tape on top of the base tape and label it with a U. This will be the U tape. It's the charge tape. We charge it by quickly ripping it from the bottom tape, which removes some of the electrons. Next, you place the U tape on the edge of the table and record some interactions with other objects, mainly some negatively charged objects, which you can get by rubbing some plastic through materials such as cotton, and other U tapes, which will have similar charges. Next, we place the U tape on between two suspended surfaces, and take another U tape and hold them close together and measure the distance between the two similarly charged tapes. This will allow us to calculate the net force and eventually the charge. Here are the observations we made during our lab. The U tapes, which had similar charges, repelled each other, as described in Coulomb's law, so that was expected. And U tapes were attracted to objects, which are said to have negative charges, which shows that the U tapes are positively charged. Finally, the U tapes, which repelled one another, had a distance of 1.5 centimeters between them, which is shown in that bottom image. And then the top image is the U tape being attracted to a negatively charged object. Some key assumptions for our calculations. All forces, such as air resistance, are negligible, except for the electric force and gravitational force. The two U tapes that are used are equally charged, and the tapes act as point charges on one another to simplify the calculations. And here are the calculations. So, as you can see, the free body diagram only includes the force of gravity and the electric force, which allowed us to calculate the charge of the tape, being 8.5776 times 10 to the negative ninth. We calculated from this that the number of electrons, or the electron deficit, is 5.3543 times 10 to the 10th. And through some further calculations, this showed that for every 5.6 times 10 to the 6th atoms that is on the surface of the tape, one of these atoms is missing an electron. This is the code that modeled this situation. You can see some of the constants included some of the things that we measured in the lab, and it provided us with this, which is the bottom U tape, which we were holding, exerting a force on the top suspended U tape, which has an equal force of gravity, being the orange vector, and electric force, which is the green vector. And again, the code gave us the same result as what we calculated. So a little bit of a discussion. Since the tape is held suspended motionless, because of Newton's second law, we know that the net force is zero. Thus, the electric force is equal and opposite to the force of gravity, which allowed us to make the calculation for the charge and the number of electrons. The electric force observed is due to a positively charge of the tape due to an electron deficiency on the surface of the tape. And some potential source for error include inaccurate measurements. Maybe we didn't measure the length of the tape wrong, and so we got the mass wrong, and net forces would be off because of that. Some unjustified assumptions, such as like air resistance not playing a factor. If that were the case, it would affect the outcome. Rounding errors in our calculations and inaccurate constants, such as acceleration due to gravity. If we had precise measurements, it may change the results a little bit. And then finally, conclusions. So what would happen if the charges in the system were reversed, as if electrons were positively charged and protons were negatively? Well, there would be no observed change in the data collection process, because opposites attract and like charges repel. By inverting their charges, the tapes would still act in the same way in the presence of like charges, and they would repel from one another. And why is it important to isolate the system from outside charges? Well, outside charges can have a very large impact on the results of the data collection. As I said in the potential sources for error, since the force is extremely light, the force to move the tape is so small, any outside intervention could change the final results drastically.